Right, so we are recording. Cool. So, hello everyone. Hope you had a good weekend. Thanks for joining this. It's my first time ever doing a stream. People were asking for a stream for a while on Discord or friends, and I wasn't giving it to them, and I felt bad. So I was like, I have to do something, right? And it was almost a uniform reply from them that they wanted the stream to be unscripted. So no prepared code, no plan, no schedule, nothing. Which is interesting, but I think it's good. I decided to go with it. So I want this to be relaxed, as if we were a bunch of friends hanging out together, talking about stuff, whatever we want. I think we're a small group today, so we have the luxury to talk, chat, ask questions, and so on. And we'll also write some code, right? Of course, I have a basic agenda, as you can see, I hope, right here. And this is simply so we don't lose track, so we can do some things, So we'll start with a small introduction. I will tell you a little bit about who I am, what I do, and so on, and how I ended up here on this stream. You can also ask me questions. You can tell me a little bit about yourselves. And then we will look a little bit about the history of the engine, how it started. I have been working on it for about 7 years now. And many people ask me, like, how have you been able to do this? It's so much work. I don't know how you did this whole thing, and so on. So we'll answer all that. But we'll also see a little bit about the architecture, a very superficial view. So we won't spend an hour talking about architecture. But we'll see the basics, so we know what we're looking at when we're writing code, or when you come back later and you look at the engine. So if you say you want to do something with physics, you at least know the right direction to look at, right? So that's all. Nothing more complex than that, no worries. And then we'll talk a little bit about how we can contribute to the engine, if somebody wants to do that. It's pretty simple, there are not a lot of rules. I just would like to discuss a few things, mainly to make the people more relaxed about contributing. Some of them are a little bit worried or scared, I've noticed. And then I will do something really basic, which is how to clone this thing. Because it's out there, it's on GitHub. So how do we clone it? How do we generate project files? So a solution for Visual Studio, right? Because when you clone it, all you get is just the code. So we have to generate a solution out of that, and it's pretty easy, and then build that and then run it. And if we have time, because I don't want to make this a very long, boring stream, right? I want to keep it nice and short and sweet. We will also load the scene, play around a little bit with the editor, and see exactly how this engine works. And after that, we will make a small window ourselves, like a small coding demo. Where we will select a mesh on the screen, an object in the scene, and that will show us information about that mesh, how many vertices it has, what model it comes from, and stuff like that. Now, that might seem simple, but that's good because we wanna, not take a long time today because we have an agenda there. But it's also good because it will allow us to see the general theme of the engine, how it works. How can you access a system in the engine and get some data? If we see this theme, then we can do more complex stuff in the future. So that's why I will not be doing something like Vulkan today or something extreme. But we'll be doing stuff like very hardcore, low-level stuff in the future. But for today, we just want to wrap our heads around how this works. How on earth do we go about creating a simple window and doing anything in it? And after that's done, you will see that we'll be able to move forward much easier. And after that, we can also close with a small chat, some questions, anything you want. This is again, I want this to be a very relaxed kind of hanging out with friends, not like a strict tutorial or a strict lecture or something like that. This is just me writing code. Imagine you were here with me and we were just talking and writing some stuff. So, a small introduction, and also why I do this. Maybe you would like to type in the chat your name and where you're from as well, and I can tell you a few things about me. So my name is Panos, that's Panos. Few people can say it, and that's fine. It's a Greek name. So I come from Greece. I studied computer science, and from an early age, I loved video games. I loved writing code, and I wanted to get into the game industry, right? And the engine is also part of that, how I used it to get into the industry, and we'll get to that. And so I came to the UK. I worked for Sony Manchester for a little bit. The project got cancelled, unfortunately. And after that, I worked for Codemasters. Dirt 5 is the game I worked on, maybe you know it, as a senior graphics programmer. And after that, I joined AMD, working on multiple games with multiple studios. So my job is pretty much, GPUs and engines and all this kind of stuff. Sorry, I have a few emails coming in. And that's pretty much my story. And nobody wrote in the chat. Okay, guys, you're pretty silent. Okay. So now the history of the engine, how it came to be. Many people ask me, like, how were you able? I don't know how you were able to do this. Make a massive engine, work on it for 7 years and so on. And I think the answer is necessity. You see, I came from Greece. I wasn't coming from a rich family. I didn't have like a bunch of opportunities, like money to do this, do that, go there, nothing like that. If anything, I had to work as a waiter a few years to make ends meet, right? So all I had to think forward to, it was a degree, a computer science degree that everybody has. It's nothing special these days, right? But my goals were like joining the game industry and stuff like that. So they were pretty unrealistic compared to what I was, right? And that's how I started to think about what can I do that has value to a studio, and I can also learn things. And that's how the engine started, basically. It was a necessity. I had no other option, at least in my mind. And that's how you do big project. So I'm not super smart, I'm not a genius, I'm not an expert. I'm sorry to disappoint you. But I'm very stubborn in the sense that if I see a goal, I will put in the time. So that's all about how this thing came to be, right? And it worked, guys. So having this, or having any kind of source code in your GitHub or anything like that, is very beneficial. Apart from having a degree and so on, having something like that in your CV, I think will help you as well. I think it's the future of CVs, actually. Just have some source code online if you're a coder. And you have any questions so far? Anything you'd like to ask me in the chat? Or any suggestions? Cool. Very cool. So the next thing I would like to show you, finally. Yes, so somebody's asking if I started the engine before moving to the UK. Yes, I started the engine in 2015, and I moved to the UK in 2016. So that was about a year where I didn't know anything about C++. I didn't know anything about DirectX or graphics programming. So I had to learn this while also writing an engine, which was insane. And I had to do it in a year because I was running out of money and I couldn't pay my rent as a student. So it was insane, guys. I never want to go through this again. I was putting in like 100 and plus work hour weeks, which means every day 12 to 13 hours just writing code and trying to figure out things. And it was very tough to do a basic engine, of course. It's not a complete engine, but something basic, but something that's there in a year. So it was a year before coming to the UK. So it was a last moment idea, basically, on how to escape my situation and maybe make my dreams come true, right? So that's how this thing started. Oh, I see some questions. Let's wait a bit before I go into the coding stuff. Can't see anything nor hear. I think others, they ask me questions, so they must be able to see me or hear me. So, can you guys see me and hear me? Excellent. Cool. So if somebody's having a problem, maybe it's something local, guys. Excellent. But don't worry so much. I'm recording this right now, so I will upload everything on YouTube, right? So don't worry too much if you have technical issues. So yeah, let's see a few questions. You mentioned the initial goal of the engine. Was it the long-term vision? Can you clarify a little bit, Dimitri, about that? Do you mean if I was planning to work on it for years? Yeah, I see your question. So if I was starting the engine to just work on it for a year, get a job in the industry, and then forget about it. Yes, but I keep going for 7 years. So initially it started like that, like a ticket out of my situation, right? And into the industry. And then it became something that I really loved. I happened to fall in love with shaders and GPUs and stuff like that. And I just kept doing it. And it became very addictive. So that's why I ended up working on it for 7 years. So it was also luck. Or maybe it wasn't. I don't know, because I was thinking about something to do that would get me to the industry. But at the same time, I was like, if I am to do something that, there is so much work involved and it's so difficult to absorb it and do, I have to be passionate about it, right? Otherwise, I will never finish it. I will become bored. So maybe that's why I also ended up loving it and working for 7 years. Yes, Nick, that's very correct. Like as I worked on it, my vision evolved as well, and understood how much more I can learn and how much more I can gain from that. So pretty much that's it, guys. You get it. So let's look a little bit about the architecture overview. We're also right on time, which is pretty good. Right. So if you Google Spartan engine or just go to GitHub and type that, you will land on this page, which is the page of the engine, right? It has a few screenshots and some bullet points about what it can do and what I'm currently working on. I'm quite slow and stuff like that, right? And let's do a basic overview of how this thing is made. First of all, the engine is split into two sections: the runtime, which is the engine, and the editor. The editor is a separate project which uses the engine as a library, right? And it just creates windows and stuff like that and buttons and so on, and the engine is used to do the whole rendering stuff. But the main thing, the most complex thing we have to know is really the runtime, which is the engine. So this is where the engine is, right? Runtime. And before we see anything here, I have to go to the core and the engine and show you that the whole idea in this engine is very simple. You have a single object that is almost in every object, in every place in the engine, and that's the context. The context is nothing but an array of subsystems, right? Subsystems are basically modules, parts of the engine that you can attach or detach. So you can make the engine as you wish. You can make it very lightweight, or you can add a bunch of stuff to it. And all I do in the beginning is add the settings subsystem to save settings regarding the rendering and stuff like that. A window subsystem to create a window, right? An actual Windows window, I mean. A renderer, a profiler, physics, audio, and so on. So everything in the engine is a subsystem. So that's how it works. And in every place that I do any coding in the engine, all I typically do is I take this context and I'm like, get subsystem. And I get a subsystem and then I do stuff, right? So when you see all that, which is the runtime directory, right? A bunch of stuff here. Don't get nervous. Don't get anxious about what is all that. Chances are every directory is simply a subsystem. So it's just a module, right? So if I go, say, to rendering, which is big as well, don't be afraid that you go to renderer and you look at what it does. It implements the iSubsystem interface. So it can be used as a subsystem, right? So that's pretty much how it works. If you go to physics, the physics is also a subsystem. There you go, right? So everything in the engine is a subsystem. It's that simple. So whenever I want to do anything, and we'll see some coding later, all we have to do is mContext, that's the variable that contains all of the subsystems, and think about what do I need to do, something rendering related. So get subsystem render from that context. So it's quite simple. And there is an audio subsystem for audio, obviously. There is an input subsystem for input from gamepads and keyboard and so on, physics, right, scripting and all this kind of stuff. So everything is just a subsystem, and you can totally ignore it. It's not hard to code it into the engine. Everything is modular, right? So I think that's all we need for now. The rest we will see as we code. Now about contributing to the engine, right? Many people, especially lately, try to contribute a little bit in the engine, which I really appreciate. It's a great thing. And I have here some guidelines on how to write code, but they're pretty generic. I say, like the first bullet, try to follow the keys principle, which means keep it simple, stupid. So that means just do simple things, don't do anything complex, right? And also choose the right tool for the job. Abstain from dogmas like only use Orthodox C++ or only modern C++. That's because there are people out there who have very valid reasons about using all the modern latest C++ stuff. And then there are people out there who have very valid reasons about using old school, the C style almost, language. But the truth is that with everything in life in general, right, the truth is somewhere in the middle. You have to use the right tool for the right job, right? So that's the idea. Just keep things simple and use whatever you want, as long as you think is the best tool for the job, right? It's really that simple to contribute to this engine. It's so simple that I'm thinking about even deleting this, because it's all about just do sensible stuff. Just pick the right tool for the right job. There is no requirement to write in a certain way or use certain C++ features or so on. And another thing regarding contributing, a lot of people have tried to contribute, and it's great. And I've noticed a trend. Some of them, I think mostly younger people, they try to do something and they do it, and then they go for something even bigger. And they're like, I'm gonna do this. And then they try it and it doesn't quite work out. They realize it's too complex, and then they disappear from the engine, from Discord or so on, and that's fine. So what I want to say is I'll also relax. There is no deadline, there is no expectation to do anything, You can try whatever you want. If it works, great. If it doesn't, great. It's fine. That's our little playground. There is nobody telling us what to do, and there is nothing wrong with not getting something done, It's not like a job. So don't be afraid to try something and then it doesn't work out. It's totally fine. So contributing, basically, it's pretty relaxed, yeah? Not many rules. Just do what you think is sensible when it comes to writing code. And don't be afraid if something doesn't pan out. It's an engine, it's a massive engine, So, right, cloning, building, and running. So how do you get this? This is that source code. There is no Visual Studio project in here at all. So typically, if I can do this correctly, because this is totally unscripted like we said, so maybe nothing works, or everything works. Visual Studio is quite good these days at doing everything Git related, so you don't have to write any commands if you do it right. And usually you can go to File in Visual Studio and clone repository, right? And then all you have to do is type the URL. So literally you just have to do a copy and a paste, and then a location, right? And when you do that, it will take a minute or two. It will download a bunch of files, and in the end, you will have a folder like that. When you open it, it won't have any Visual Studio solutions. It will be like that. It will be pure code, right? You will look inside. Let's delete that as well. and it will just be code like that. So you can't really run anything. There is no project, a Visual Studio project. So all you have to do is click one of these guys. And now this brings me to another point. This engine has a D3D12 and a Vulkan backend, which are both under construction. I'm still working on them. Vulkan renders sometimes, but on some PCs it might not render. It's in a beta stage, right? And D3D12 is half done, so don't use that. Right, maybe it would be good to go over which features, workloads you installed for Visual Studio to set it up. So if you install the latest Visual Studio, so my version was what? 2022, right? Let me check again. Yes, so if you have the latest Visual Studio, you won't have to download anything specific. It comes with the Git abilities. I think so, right, Nick? And you can just do what I showed you. Take the URL and it clones the project, and you have the files here. C++ workload. Ah, I know what you mean, guys. Yeah, when you install Visual Studio itself. Yeah, let's try to see that actually. So I think you're referring to the actual installer, right? Yeah. I see what you mean, guys. Good shout. Thank you. So when you install Visual Studio, there is a bunch of options. I think that's what you meant, guys. So you have to have the C++ stuff, right? Obviously, that's a C++ engine. And what else? Game development with C++. I use that as well. And that should be it. That's literally what I did. This system is quite new, and literally what I did is that. You see it's checked as well. And it should be ready to go. Okay. And like I said, D3D12 and Vulkan are still under development. So for now, if you want something stable to play around, you should use the D3D11 version. So that's a script that you simply click. It's running here. It's doing a bunch of stuff. I will tell you in a little bit. And it will generate a Visual Studio solution. Yep, there it is. Cool. Yeah, thanks, Nick. I get it. Thanks a lot, man. Keep them coming. Good suggestions. So now we have a Visual Studio solution, which means we can run this. And by the way, all the script did was, first of all, go to this folder, and there is a zip file, and it contains all the libraries the engine is using, right? So it unzips them, so we have access to them, and it just links them to the project after it has generated the project. So you don't have to download anything. The engine will just run and compile. All the libraries are there. So once you run the script, you have your solution, and you click it, and now you should actually see like the project. And what I told you before, you should see a runtime and the editor. The editor, which is the whole UI, is using the runtime, which is the actual engine. All the cool stuff are in the engine, right? And you should be able to start that, and it will build it, I hope. Thanks, man. That's good to hear, guys. A smooth building experience is all we want, guys. A single click, and everything should just run. It started in another window, but let me bring it over. Hope it doesn't crash. Excellent. So it will just start like that. Yes, Visual Assistant did. It's the best, man. So that's how it looks, right? And we have a little bit of time as well, so we might as well see a few things. The engine, it has this asset window here, and it shows you the kind of resources you have, right? So this is in the binaries. That's where the executable is. And everything you want the engine to be able to see it in here, in the assets window, it has to be in the projects folder. You see? So models and all this kind of stuff, that's it. So anything has to be in the projects folder. The engine doesn't do it automatically at this point. You cannot import something and it puts it there. You have to put it there. And then you can click on import. Oh. And you can select a model and load it. I have a few here, but I already have a nice scene set up, which is just a model I loaded previously. That's the only setup I did. And it's a debug build, so it should be quite slow. That was fast actually, but it's a debug build. So that's the engine, right? And you can move around. The camera is a little bit wonky because my mouse, that's what's happening, is moving from this monitor to this monitor, and it's getting kind of freaky there. But basically, it's like Unreal controls. With right click, hold that down, you can control the camera, and with WSD, you can move around, right? So it's fairly simple. And that's pretty much it. And a cool thing you can do is you can go up here with this gear icon, and you can click that. And that's where most of the effects are. Some of them are working, most of them are working. Some of them might be semi-working because I'm always improving and tweaking stuff. But you can see them in action. TAA, for example, you know, you can see how noisy things are there, for example. You enable TAA, all smooth and nice. AMD CAS, contrast adaptive sharpening, to make it sharper as well. It's a tiny little detail, I don't know if it's visible. So this is a nice window to play around with. And if you want to write shaders or anything like that, you can also straight up click that, and that's a shader editor. So it shows you all the shaders that are in the engine right now that are used to do stuff. So you can go to, say, SSR, right, and click that, and you can write something in the shader and click compile, and it will automatically, on the fly, next frame, show you the results. So you can write real-time shaders. So you can put a scene on that you like and play around and do cool things. And the shader is saved there, right? What else? What else can we see that's pretty cool? We have some time. We can have a look at this. This is quite new. This is the texture viewer. It's quite new, so you see the alignment of the buttons is not so great yet. Oh, that's the viewport. That's a texture viewer, that's what we want, right? Ah, that's better. So this shows us the actual internal render targets of the engine. So that's the albedo. The normals should be without the alpha channel, yeah. So you have to be careful what you're seeing, right? You can control the channels here. So that's the normals. What else? We can see SSR, how it looks. You know, it's a pretty diffuse scene, pretty rough scene, so there's not a lot of reflections. But you can see, you know, a couple of stuff. Ambient occlusion. That's it. It's not looking great because I have been messing with it, trying to improve it. But you get the idea that you can use this and you can look at render targets and then look at the individual channels, what I'm doing there, what kind of data do I have in each channel, and gamma correction or point sampling and stuff like that you can also do, right? So this is pretty much how it works. It's a pretty simple engine. And the console here and the world is here. You can also click stuff and it will select them for you, it will find them. And it also has, you go here, you click on transform, you can actually see a little transform. It's not perfect, but it's there. Again, this window, the render options, has a lot of cool stuff like axis aligned bounding boxes and so on, and various cool things like that, right? So that's pretty much how it works, and there's nothing more to it. It's pretty simple. So I suggest, to make sure we have time as well, but we do some coding. The idea I had, so we can get an idea of how it works without taking like 2 hours with the stream, was to create something like that, like a little button here, that you click it, and a window that's called Mesh Viewer pops up. And then we can click, say, on that or that, and it will show us, depending on what is selected in the viewport, what kind of mesh is that? How many vertices does it have? What's the bounding box size? What model does it come from? What's the name of the mesh? You know, and that might seem simple, but it will actually show us how to create a window in the engine, how to use in GUI, which is the UI library I'm using to do all this stuff. And it will show us how the engine works, because again, this context subsystem will come into play. So you will see how we will access the world, which is this, and ask the world what object is selected and get that object and so on. So you will see the common thing that you have to know. And if you know that thing, you can pretty much start exploring the engine and do other stuff, because the theme applies everywhere. There's nothing hard-coded, it's the same kind of stuff. Subsystems that you access, you get your data, and you go about your business. That's pretty much it. So let's try to do that, right? Again, create a little button here, click it, and get a window initially showing up with a title. Like here should say Mesh Viewer. Let's start with that, right? Start simple, because this is totally unscripted and everything can go wrong, horribly wrong. Good thing is it didn't crash yet. Right, so the first question is, I want to create a window, right? So I'm referring to the editor. So I go to the editor project, and then I have a folder or a directory called widgets. And then here you can see all the widgets that the engine uses. The console, the asset viewer, the render options window that we just saw. Absolutely. Is that better, guys? Lots of noise I had. Yeah, good. Load with some lag, huh? That's interesting. I had a good connection, guys. I don't know what's up with it. Maybe Discord, maybe you're right. But again, I will upload everything on YouTube, so hopefully, nothing is lost. Everything we see today. So yeah, the first question is, I want to make something in the editor, right? Because I want to make something in the editor, I have to go to the editor project, and you just use common sense. I think it's pretty simply laid out. And you want to create a widget, which is like the properties, the render options that we just saw, something like that, right? Discord Nitro, okay. Higher quality stuff. I see. So the first thing I'm gonna do is have a look at the render options and see how it works. So all it does is implement another interface called widget, which if you implement, the editor will be able to show in it. It's that simple, right? So the first thing I'm gonna do is create a new file here, right? I'm gonna do this again in case you didn't see it. Just right click, right click, add new item, right? And then I'm gonna add a header file, and I'm gonna call this Mesh Viewer, right? It's gonna be a little window, and I'm gonna seamlessly copy everything from here, right? There is no reason to write all that, and I'm gonna rename a few things. So we're gonna call it Mesh Viewer, right? It's gonna implement the same interface. It's a widget. Obviously, the constructor is called Mesh Viewer, and that's a virtual function that comes from the widget interface. And we don't even need that for the time being. Maybe we do. We'll see. And now we'll create so many windows here. I have to remove a few. We'll create. What am I doing? Stack. Cool. A CPP file, which will be, again, Mesh, you guessed it, Viewer. Cool. Excellent. So now I'm gonna go to render options again and just actually something smaller. Copy a few stuff again, guys, so we don't have. Yeah, that's more than enough. Copy this, right, and make this our constructor. Delete all that, and Visual Assist. and include for us the header file we just created, right? So we include that header file, and all we do is implement this constructor, right? And let's also implement with Visual Assist the tick function. The tick function is what runs every time the engine updates, right? So if we give it a title like Mesh Viewer, the engine will do the rest, and it will create that window, and it will call it Mesh Viewer. Of course, if we run it now, we will not see anything. Let's have a go. Because it's there, but we didn't add it. Let's see here. It's there now, it's in memory, or it's not even in memory yet, but we didn't add it anywhere. So we have to hook it up somewhere, right? So where do we hook this up? So all you have to do, let's close that, the rest. You can go to Solution Explorer and go to Editor. It's just the main editor file here, right? And all the way down, I have something very simplistic. Where is it? There, initialize. It's something super simplistic. It's a, what is it? A vector of widgets. And we just add widgets there. So all we have to do is this. And I'm going to rename that to Mesh Viewer. And obviously, we don't have the header included. So Visual Assist to the rescue. It will just add a nice little include here, right? So let's see what happens now. Will we see anything or not? I don't even remember. I also want to check it out with you. Ah, we see something, right? There are more steps to make it a button here, and then you click that button and it starts. But that's a good start. So there is a window that's called Mesh Viewer. Right, so that's in the UI running in the background. So if I go to the widget interface, all it does is let's go to the CPP file. Widgets, widget, that's what it is. So all it does, the widget interface, if you've seen in GUI before, it just runs in GUI on the background, and if you have set any options like transparency, window title, whatever, it will just set them and start a window for you. So it's doing some pretty standard in GUI stuff that because they're pretty standard, they're in the interface, so you don't have to do them all the time whenever you want to create a widget, right? So it's that simple. And say we wanted to make it a button. So say we wanted to make this Mesh Viewer be a button up here, right? So when you click it, it shows up. It's not just there all the time, right? Oh, stop debugging. So I don't even remember that, for example. But what I'm going to do is I'm going to go to the menu bar, which is this. I think the menu bar is actually the menu bar or the toolbar. That's it, guys. Let's figure this out together. So let's see. Yeah, that's pretty much it. Oh, right. So the menu bar, guys, because I even forgot. You see, the menu bar is that top bit. These things. Now the buttons are coming from somewhere else, I guess. Let's find that out. So we can click on a widget that's used as a button, like the profiler, and see who actually calls that thing, where it's being called, right? If you do Alt-Shift-F on an object, it will actually show you references to that object. So, right. Alright, so there is a toolbar, actual CPP file. Where is that, guys? Ah, it's there, I just missed it. So there's a toolbar, which is actually the toolbar with the little icons. And it works in the same manner, right? So it gets from the editor, where we added the widgets, a particular widget, and it just sets it to a particular button. So let's try that. Again, the code is not perfect, by the way. It's just stuff I did over the time, and it just worked. So I'm just going back and seeing this with you as well, and I'm trying to figure it out, right? Right, so you select an icon for the button, I assume, and a widget, and it just makes that button, right? Cool. So I could say, just add another one. Icon type, I don't know, something random now, guys. We won't pick a proper icon, just yeah, collider, whatever. And then get the mesh viewer. And let's see if that will do it. Right? Let's see what that will do. Right, it crashed. Right, let's see why it crashed. Interesting. That's the thing with live coding, as you see. We have to figure out what I did a few months ago. Exactly, Nick. So yeah, let's see if what it's getting here is actually legit, right? If it's actually getting a pointer of the mesh viewer. Can we look at that? So it has a bunch of widgets. It's a little bit tough to view it. But we did show the window before, so it's definitely created, right? So why does it crash here, guys? Let's run it again and see what it says. Widgets, it's null. Yeah, okay, so it's not getting any widgets. That's interesting. So if we look at the widgets in the editor, right, this is where we added our widget, right? Yes. I know why, guys. Whatever the toolbar is, maybe it's inside the menu bar. Well, guys, could it be that because you initialized it before, now it gets all wonky? That's a good shout, but I think what's happening is that the toolbar, I think it's part of the menu bar. It's inside here. Yes. So what that means is, by the time this runs, the menu bar, the mesh viewer is not even created yet, and it will try to get that. So all we have to do now is just get this and put it before the menu bar. So by the time the toolbar runs, within the menu bar, it actually finds a valid mesh viewer. So we did everything correctly. It shouldn't crash. It didn't crash. That's great. And we have a weird little icon here of a collider. Very close indeed, Nick. And thanks for the help, mate. So we have now this, but of course it doesn't react at all. So how do we actually make it like work with the button? Well, I think the answer is pretty simple. I think because I did it many months ago, I think the answer is in the constructor of a particular object. You have to tell it if initially it's visible or not. And I think that's all there is to it. So if I go to my mesh viewer and I'm like, this is the title, but when it comes to the visibility, what was it? I forgot, guys. It's just visible, right? And set that to false. So it's not visible by default. I think that should be it. It shouldn't show by default. It doesn't, that's good. If I click it, I get it. If I close that, I get it. So that's all. Basically, if you hook it up to a button, you just have to say, don't be visible, right? Because the button will just handle that. Right, so that's all there is to it. So now we can go on about doing what we said initially, which is what? Let's see that again a little bit. What we said is, we will load the scene. We will load the scene like so. And what I want to do, guys, is I want to have this thing somewhere here, right? And then I want to click on this, and I want this window to let me know the name of the mesh, how much vertices it have, how many vertices it has, how much memory it takes, you know, stuff about it, right? So how we will go about this, working with this engine? This is a thing in the world, right? It exists in the world. So the world subsystem is probably where we have to look. I say probably because I haven't touched that for months, right? So that's how we'll go about it. And all I have to do is go to the runtime now, and I'm gonna go to the world, and I'm gonna see if there is a function related to that. And there is. Get transform handle. Now the transform handle is these little arrows with the axes that come up. And these arrows, this handle, it snaps to an object. So it knows the object, right? So that's a good starting point. So how would I go from the editor, let's remove all that, what is this, and get that object? Well, all I have to do is, I have a context, which should be initialized, I guess. Let's see, other tools, how they do it. Yeah, I think the context should be already initialized by now. Cool. So I have this context, which I remember I told you about this. It's the main thing, the first thing the engine does when it starts. It's just that, right? It just adds to the context pointer, a list, basically a vector, all the subsystems. So I'm gonna use that, which is almost always in every object you use, in every interface you implement, there will almost always be a context object waiting for you. And all I have to do is get subsystem world, right? And then from that, I can say get transform handle, right? And also let's include the right header file. And what does that return? A set pointer, right? So I'm gonna do it like that in this case. I'm gonna be if handle. Right, so if this handle is there, and also let's include, it's complaining about a lot of stuff. Let's see if it even compiles at this point. Sometimes Visual Assist takes a while to. What did we do wrong here, guys? Transform handle is here. Silly little mistake. It has to be. I will show you now, guys. Yeah, let's add this namespace. I think that's it. If it works. Yeah, that's it. So because we're in the editor, so this is not the runtime, you have to use this namespace. You could do this, right? So it just knows that it belongs to the engine namespace, that's all. You can always look at widgets that already exist. It's always what I do. I can't remember everything, right? Even if I write this stuff, there are so many I cannot remember them. So you can always look and see how they do it. And hopefully this should compile now, right? No? Ray. Right, so it's coming with some baggage. It needs the ray. Okay. Let's add that. Probably that's a mistake on my end. It shouldn't need that. Let's see if it builds now. Again it complains. That's ridiculous, guys. So let's, you know what? Let's just get the handle and then get selected entity. So entities are like actors or game objects in my engine, right? That should work. Come on, we get the entity straight away without checking for anything else. That's the selected entity. Let's do that. It's still complaining, guys. Transform operator. Huh. Okay, I think it needs another namespace, guys. Where is it? let's take that as well, the math namespace, because I think the array is a mathematics object in my engine. Oh, that's it. So let's add that as well and be done with it. Again, it's complaining. That's impressive, guys. Right. The error says that there is array definition here in the transform operator, which is the transform object, and cannot find it, which is interesting. But let's see if we go to other places where the transform handle is used. What on earth is it doing there? You know? What does it include there? I don't see anything special. You see, that's the thing with live coding. You always have to solve small things like that. Ray is not a member of Spartan Math, isn't it? It is. Okay. Let's see, guys. We'll figure this out. We just need to see. Let's see other widgets, guys, and see how I do things, like these render options. All this stuff, I'm just gonna take them all in this. Just put this there. Be done with it. All the namespaces that you need. That's a namespace that helps me out. Okay, what about now? Again, the same. Okay, let's put array here. Say I want to create array. What will it do, guys? Array is undefined. Okay, I include that. Still the same. Namespace math. I added it here, so you shouldn't need it now. The namespace math. Ray is on the member of Spartan Math. Something is weird, guys, here. Okay, let's try that. Remove that. Still the same. What if I remove that and I just leave the included? Still the same. There's something wrong with array, I think. What? Transform handle. Let's try rebuild. That's right. See what happens. If not, we will work around that. I have an idea. Just for a little demo, you know. Okay, let's work around that, guys. So to avoid now dealing with this, so we can see something related to how to do stuff in the engine, let's go to the world and we'll create another function which straight up returns the selected entity, right? So get selected entity, right? And we'll do that internally. So since this compiles, we'll piggyback off of that. So we can say, what was it? Transform handle, get selected entity, and it is a pointer. That's good. So we return that. And hopefully we can just forget about all this mess and don't spend an hour and just say get selected entity and see if it compiles first, guys. Let's see. Okay, the context. Okay, let's include the context. This is just missing a few definitions. Compile now. Yeah, make any issue you want, or cool, it compiled, guys. So we worked around that. It's probably some sort of header or namespace issue we encountered, but sometimes they can be pretty messy. You can get lost, and I don't want to invest, say, half an hour now figuring this out. So we have the entity that's selected here, right? So all I want to do initially is, if this entity is not null, this if statement will enter. So let's simply log its name initially. That's all. That's a macro that you can use to log into the console, right? And that's, you know exactly what it is, right? C++. And get name, get object name, whatever. That's a C string, right? And let's see if it prints anything. That also needs to be included. Cool. Entity as well. Okay, let's include that as well, guys. That's why Visual Assist is so convenient. You see, if a symbol definition is missing, you can just hover over it, and it will just tell you, you know, should I include this? And you're like, yeah. So it's an invaluable tool, guys. And now, if I click on something, we should see something, right? We should see the console here going crazy and printing every frame the name of this object. And it didn't, it crashed. Why is that? That's a threading issue. That was a random crash, guys. So we can try this again. And it can hopefully work. Right. Let's try this again. Hopefully it doesn't crash randomly. It did. Man. That's a threading issue. So let's try it again, guys. It's loading the scene, the entire scene in a different thread. So things can go wrong sometimes. But it's not so often that it happens. So we should be fine. Yeah, now we're fine. I don't want to jinx it. So I click that. Cool. So we get no entity yet. Maybe because the window's not running, right? So we have to make sure this is running. The moment it runs, it tells you spawns at 334. Is that correct? Let's see. I'm gonna find it there, and I'm gonna click it, and I'm gonna see if it's the correct thing in the scene. That's it. So that's how you get something in the scene, for example. And we can close it now and start doing some proper GUI, some proper UI stuff to get this thing to populate a little window, right? And let's comment that out, right? And in GUI, you can do stuff like that. In GUI, that's not the engine now, that's the GUI library, right? That you can use within the engine, it will automatically work. You can say text or something like that. And it needs also a C string, right? You can see that here. So all I have to do is take this, paste it here, right? And see now if we're going to get anything in the window that's an actual UI element, right? We don't want anything in the console. We want stuff within the window now. Right. Let's load the scene. Hopefully we don't crash again. This threading issue is quite sneaky. Cool, I think it's fine. And bring that up. Click that. Beautiful. So we can see text now within the window. So that's what you use to build stuff within the editor. It's the InGUI thingy, InGUI library. And you might have seen it. It's a massive library. It's used in many games, many engines, many studios. I always see this, right? Look at that. It's absolutely massive. And it creates windows exactly like that, right? So it's already hooked up in the engine, and all you have to do is use it. Yes, you were using Qt before in GUI, right? Yes, that's correct. I was using Qt, and before Qt, I was using WX widgets. WX widgets was the worst. Qt was way better, and it works really well and it's fast, but the license is not so permissive. There's also a paid plan as well. But this thing in GUI is MIT licensed, totally free, easy to work with. You see how fast it is to make a window and have some text in it. So this has been by far the best, guys. And I strongly advise you to go for it if you have a project. Just go within GUI, it's everywhere. Right. So what else could we do here? Yeah, we said we would like to have, say, the number of vertices that are within this mess. How many points, to put it more simply, make up this mess. So let's see that. Can we get this kind of data all the way from the engine into our little window? And what I will do is select entity, and again, a similar theme appears, guys, which is get component. This is very much like Unity or Unreal. So I can tell, give me the renderable component. That's what holds the mess and all this kind of stuff. And by the way, if you don't know what kind of components there are, you can always use, common sense. I think the engine is pretty clear in this regard. You can go to the world, and you can go to components, and you can have a look at anything that is there. Rigid bodies, colliders, cameras, and so on, right? So I want to get the renderable. And of course, maybe the mess doesn't have a renderable component, right? So I will do that. I will say in an if statement, right? If there is a renderable component, get that, right? And if you get that, we will enter this if statement. Cool? Cool. So this renderable component should have data like the kind of data we want. Let's see what it has. Get vertex count. What about that? Let's try that. So I'm gonna make another text here, similar to that, right? And I'm gonna say text, and actually, you know what? It wants a C string, right? And we're gonna get a number from it. So let's see what we'll do. Vertex count. So that's a number, right? But this thing wants a string. So if I recall correctly, there's a function called toString. That's from the std namespace, and it will just convert a number to a string. But of course, this wants a C-style string, right? And this is a typical std string, so we have to do this. And hopefully, if everything is correct, let's include the renderable component. So this goes away. Cool. See if it compiles. Hopefully. Oh, what am I doing, guys? It's a mistake. Close the parenthesis here. That's the string. Do that. Let's see, guys. What did we do? Right? Load the scene. Hopefully we don't crash again. Select a mess. That's it. 1075 vertices. This little thing here. But of course, this doesn't make a lot of sense. So let's add a few more things. So we want a label that says vertex count, and then next to it, the actual vertex count. So I will do that by doing, before that, in GUI, then you can do label text, or you can do text as well, it's the same, pretty much. And you can say vertex count. You could also do it within the same text, right? Vertex count, and then just add the number. But let's do it like that on purpose. I want to show you something. So you do it like that, and you build that, and let's see what we get. Let's load the scene. So many windows popping up in different monitors. Let's click that, and you see that the thing that happens now, we get this vertex count text, but the number is below it. We want it to be next to it, right? So how you can do that within GUI is simply say in GUI same line. It really is that simple. And if you do that like that, we should see them next to each other, right? It always defaults to another screen for some reason, guys, and I have to keep dragging everything here. Right, let's bring that up and click that. Right, that's better, right? Vertex count, and that's it. And that's the name. We could do the same for the name. And we could do something like in GUI text, we can do that straight away, right? Mess name, and then in GUI same line, and we'll get the mess name as well. And also we'll go even further than that, and we'll add a button that does something. It prints the name if you click it in the console though. So we can say if in GUI button, and it really is that simple, guys. Log, we'll call it. If that button is pressed, that's what it means. It's also created the moment you're using it, but it also means if it's pressed, this returns true, and in there we can do that, right? We can do this. Let's see what happens. Let's see. So load this in first, right? Oh, I was too fast, guys, and we got the threading grass. Let's try again. There's a whole lot of stuff we can fix, guys. So many issues we can open on GitHub. Right. Again. Let's go again, guys. It is what it is. Unscripted live coding. Let's do that, and hopefully it doesn't do it for the third time. Yes, it looks stable. So click that, and we have the mess name and the sponsor thingy next to it, and below that we have the button. So if I click that, remember, where are we? Let's go here. If I click that, it should log into the console using this macro, right? The name of the entity. So let's do that. We're gonna clear everything on the console, and it does just that. And the good thing with this macro as well, if you see, apart from the stuff you're logging, which is just the mess, just the mess name is what we're logging, right? That's all. It also tells you where it's being logged from. So mess viewer, tick visible function, log that. So the console is actually very helpful as well when you want to see what's going on where. If you look at it closely, you can see exactly where things are coming from. Of course, this is less than ideal to use for debugging, but it's also something that can help, right? You can see where things are coming from. And say, like, what else could we see from the mess, from the renderable? It has a geometry type, geometry name. Geometry type, what kind of type is it? Custom, default cube, stuff like that. Okay, we don't really care about that. What else is cool that we could get material name? That's interesting. So from the mess, we can even get the material that is used to actually draw it. Let's try that. Let's see if we can even tell us the material, right? So apart from the vertex count, we're gonna add very similarly the material name. Let's see if we can get that too. And you know, these are basic things, but basically we have already seen how to access a subsystem. This could be the renderer, this could be the physics, and then you get it and you can do stuff with it. And we can also get components. You know, that's pretty much, it's a simple example, but you really see the theme that's everywhere in the engine. Just get components and get subsystems. That's all there is. And all the engine is subsystems and components. So let's see if we can get the material name as well in this little window we made. So I'm gonna go to the renderable. I'm gonna say get material. It has the name as well. All right. All right. Sorry. It's a string already. So We don't have to do that. We just have to convert it to a C string, right? And now you could even see the material. Right, let's try, guys. See what, again, the threading. Yeah, the threading is a little bit of an issue because I'm trying to use the philosophy in the engine that nothing ever stops or freezes. Everything is running in different threads, but it's a very complicated thing to do. So I have a thread pool here. There's another subsystem, right, called threading, and it just creates a bunch of threads that the engine can use, and you can issue functions and give them to the threading system. It will run them in a totally different CPU core or thread, and that's good and all because the engine never stops. It always does something. It never freezes. The UI doesn't freeze, but it's uber complex, guys. There is always something that doesn't work. Even if everything works fine, in say a year, you will find something that doesn't quite work. So let's click that, and it says that it's the vase hanging material. I don't even have to check here, even though I can see it, because I can also see that yes, that's the vase hanging material. So you can see that you can do all sorts of stuff, and in the same mindset, you could probe deeper. You could go in the material itself, because you can get it from the renderable, right? And get individual textures and get, I don't know, roughness values or stuff like that, like mess with how they render. That's the roughness of the material. You could mess with the normals. Oh, I have two monitors, so it's really confusing. Right, you could remove stuff as well. You could totally mess it up. So yeah, you can do pretty much anything. And I would like to show you, what should I show you? I think for today that's enough with the mesh viewer. Before we close for today, I would like to show you like another case where I get another subsystem. Say, let's search, who calls that? Get subsystem. Right. So, in GUI, for example, which is this whole editor thingy, it needs a few shaders to render all this stuff, right? This in GUI stuff. So where does it load them from? Where is the directory with the shaders? Well, as usual, you can do a get subsystem, and you can get the resource cache, which is just a collection of all the resources in the engine. Shaders, audio, meshes, everything is in there, right? And again, look at that. In the main directory, there's just a directory called resource, and it has a resource cache in the individual resource interface that various resources can implement. So everything is really that simple. I really mean it when I say everything is a subsystem. So you can get that subsystem, and you can ask it, get resource directory, and you can give it just an enum and tell it, I want to know where the shaders are, and it will give you a path relative to the engine as well, which is exactly the thing you want with the shaders, right? And then you add the shader name, and you have the shader path, and you can use that to load stuff. And the same applies everywhere, guys. I mean, there are things, getting the render, getting the input. Say, the input should be interesting. If I have the input if I get the input here, right? You can do like input, get key or key down or key up, much like Unity. So it really is that simple. That's why I wanted to show you this mesh viewer example. I mean, it's just a mesh viewer, but the theme truly, again, I have to repeat this, truly applies everywhere. It's just like when you come here online and you look at all this in the runtime, remember that this is all just subsystems. And if you look inside, you can see the thingy that you can do, like get subsystem. Just do anything you want with it. So that's how you go when you contribute stuff, or if you want to go online and check a few things, you can now read it much easier, I believe. And also future streams, if this works and you like it and we do more, where there will be more coding, you can follow now easier. I mean, it's just subsystems. And also, the good thing is, as you saw, it's a massive engine. It's so big. After 7 years of development, even I don't remember everything. I don't remember every part of the engine. So I think it's good that together we can see this work things out. You know, we have a problem like, oh, this thing didn't compile. How can we go about it? So I think this can be quite interesting. And with that, guys, we're already over an hour, believe it or not, doing the stream. I think for today we should close it with this messy UR, and then in the next stream, if there is one, we can either continue that or choose something else. Of course, the next time there will be less introduction and so on, since you know, we did all that, and we can do a little bit more hardcore stuff. But you see how complex things can get with an engine, so we have to be careful. We have to ramp it up slowly. We cannot go straight to Vulkan or anything like that. You see, even a little window like that requires attention. It requires effort. You know, nothing is you know, for free. So we will ramp it up slowly, and hopefully we can do some interesting stuff. And with that, I think we have another thing. Yes. Would you have any questions you want to ask, or any suggestions, or you want to talk to me about yourself a little bit, where you're from, guys, if you like this, anything. We have some time. People are still typing, they're still here, that's amazing. That was a long stream. I thought I lost you. What was your initial approach to learning the material, at least for the rendering part? That's a really good question. I tried to read books initially. I got this one, D3D11, Luna, Frank de Luna? What was it, guys? Frank de Luna, I think. Yeah, this book. That's what I got initially. And I followed it a little bit, but what I ended up doing, guys, is I ended up looking at tutorials online. I've read a few, and I learned from them, but I don't really recommend them. I would recommend something like that. So I've read stuff of this nature, where people just explain everything, shaders, and so on. So I will paste that here, by the way. That's a really good resource. And also, believe it or not, I just went and found an engine, specifically Urko 3D. I don't know why, but I love this engine. I think the architecture of this is super clear. So a lot of the rendering stuff that you asked, I've learned them actually from Urko 3D. At least architecturally wise. How do you architect and render? How do you have so many systems in the engine? The whole subsystem idea. That's from Urko 3D. So it was a mix for me of trying to read the book. Maybe I understood like 5%. Remember, it was way back then. And then I tried to do a few tutorials. Some were good, some were not so good. What I sent you is actually pretty good. And then after I got off, like I could stand on my feet and I could learn some code and stuff like that, I smashed it, guys. I smashed it with GitHub. And really, that's a really valuable resource today, guys. Because if you think about it, it's only the past decade or so, or 2 decades, that we have access to information like that for free. Like you can see some of the top coders. You can see Linus Torvalds, the guy from Linux. You can see code from John Carmack. I think Doom is on GitHub, you know? So it's a goldmine, guys. I mean, I really suggest that you take some time to look at a few things online, and you will find some really, really talented people, much better than I am, that do this kind of stuff. And yeah, it was very beneficial. So the rendering part, to sum it up, everything I learned was a lot from open source stuff. Another question. So you said that you have a non-blocking thread policy. Do you have an upper limit on how many threads you're going to create? Is it platform dependent? Bang on, really good question. I can show you. I have a limit. I think I query. There is a function in C++ land. Save that, why not? Where is it, my friends? Yes, that's it. So this returns you the number of threads that are supported on the system. So I take that, and I think I create one less. Yes, exactly. Because I assume that there is one thread already running, which is the engine. So I'm like, one less, just create the rest. So I think that's a Ryzen processor, and it has I think because I have a lot of PCs nowadays, guys, so I don't even know what this is running on. Yes, that's a bunch of threads. So that will create what, like 32 threads. So that returns the threads, not the actual like physical core count, but the actual threads that the CPU has. So in this case, it would have created 31 threads. So, and we can check that, we can run that and see if that's the case. And in the meantime, if you have any other questions, guys, feel free to ask. Again, there are no silly questions, by the way. You can ask me anything you want, and I will make sure you get an answer. 31 threads, exactly. So 32 threads, 31 is what we use. So that is the threads allowed for your application, or that's how many clear concurrent threads the processor can run. Right. So that's both. That's a good question. So that's the number of threads that the system can handle, what we get here. But at the same time, it's actually the number of threads you can run concurrently. This could probably use some optimization. Now just freely let you do whatever you want. So if you enqueue a thread, let's see, I think it just let you do it. Add task. Yeah, it just pushes a thread, a job, into one of the threads, and it starts doing it. So it can work concurrently up to 31 threads. I don't think that's efficient, but for the time being, it hasn't become an issue. I mean, having other issues, as you saw, like having a single thread doing the loading and having it crash sometimes. And also, part of why that is because I'm always re-architecting the engine, so adding Vulkan, working on D12, moving stuff around, refactoring things, and that is never for free, guys. Everything that works, when you try to mess with it, add stuff, remove stuff, tweak it, chances are it's gonna break again. So the engine is in a good state, as you saw. I mean, considering that it's from one guy, it's relatively stable, but it's never like, it's not like Unreal, right, or Unity. It's not like super stable. But yeah, that's it. Any other questions, guys, before we slowly end the stream? Anything you would like to see in the future? Any cool ideas you have? Any questions about the game industry? It could be anything. Now is your chance. I'm joking. That will be another stream, I guess. Don't worry. But yeah, don't hesitate to ask anything. We have some time. We have like 7 minutes, if we want. Thanks a lot, Nick. I appreciate it, mate. Really nice of you to say. And thanks for the helpful observations during the stream, man. Can you share the base level you open as your start debugging? I do not see how you actually import anything. So, if I understand correctly, you want me to load the model in the engine, let's say. So do you use any tool to outline the architecture of the engine? Do you mean like a way to document it, like Doxygen or stuff like that, when you say tool? Yeah, unfortunately I'm not using it, but I would be open to suggestions, guys, for sure. There are so many things we can do with this. It's massive. If you have anything and you think it's cool, it probably is cool. I just haven't thought about it. So let me know. Let me know anything you have in mind. How we can improve this. Can we add a little tool that's easy to use and it outlines the architecture? Again, there was another question I didn't quite get. It was just edited. Perfect. Can you share the base level as you open up and start debugging. I do not see how you can actually import anything. I see what you mean. Cool, so let's start the engine and let's try to import a model instead of loading a ready-to-go scene, right? By the way, I forgot something really important, guys. When you download the engine, in the data folder, there is a models folder, and it has a few models for you already, right? So you can bring these guys in here and just load them, right? And let's do a model import. So you have to go to assets and click import. That's similar to Unreal. That's where I installed it from, right? And it shows you exactly what this is showing basically. And you can go to models, and I can load the sponsor. I will load it from the beginning, right? The whole thing. So that's the OBJ file, right? Let's see what happens. That's a debug build, by the way. That's a debug configuration, so it should be slower. But it's alright. It should take like a few seconds, but it's not gonna be instant. Yes, that's correct. You need to have stuff in the project folder to load them, to see them from the import thingy. And you click on them, and they show up inside. And a person asked me before, I remember that still, why is the scale not 1? And you get weird scales like that, like 0.0004 and so on. Well, because artists are a curious bunch, so they can have a model which is gigantic, like massive. You load it and it's so gigantic, you don't even see it. It gets clipped, goes so far away. And others, they make models with a scale that's tiny, like super tiny. It's like you cannot even see it, right? And it's right in front of you. So I was like, I have to find a way to take whatever it's loading and normalize it. So make sure the size of it, the biggest dimension is 1. So what I'm doing internally is I go through the bounding boxes of the model. This is all the boxes that make up every mess, right? They surround it, and I find I compute like the overall bounding box, and then I'm like, okay, how big is that? And if it's massive, then I use that scale to divide it, to normalize it basically, like you would normalize a vector, right? And I get a much smaller scale, but I know that this is a unit-sized model. So you might see this be very big or be very small, but it's good because you will actually see what you're supposed to see in front of you without thinking like, I just loaded the model and I don't see anything, because it's like super tiny. And many times I was like, why is it not working? It was working, but I couldn't see it, right? So that's how you load stuff. And then you can just save and load. And also there are a few shortcuts. You can see the shortcuts here. To save, load, move the camera, full screen, move around and so on. You can always see that stuff, right? And to close it, maybe I should show you. I have some screenshots on how this thing started. That, my friends, is Spartan version 0.0. That's a window. That's a single window with a triangle. That's 3 vertices, right? That's all it was. A yellow triangle. That's Spartan right there. Can you give us a hint of what's new in Vulkan 1.3? I believe one of the main things of Vulkan 1.3 is its dynamic capabilities. So things like render passes and creating them and setting them and all this kind of stuff, they go out of the window. You only need render passes and stuff like that, mainly for mobile tile-based GPUs, right? In any case, so now a lot of this stuff goes away, and Vulkan becomes quite a bit more dynamic, meaning there's a lot less setting up to do, and you can just issue commands and it does them. But it's a big topic. Like we will have to actually do something to really show you what I mean. And we will probably do stuff because Vulkan is still needs work in my engine, and it's massive, and I don't get the time. But if we do the streams and we hang out together and so on, maybe we could actually go for it. By the way, that's where is it? That's version 2. A box instead of a triangle. look at this, that's a few files, a few shaders, super basic stuff. And the books had floors and some physics stuff. And then slowly, you load a model, and you load a bigger model, and you make a small editor, and you load even more complex stuff, and in the end it ended up looking like that. So that's how it went as well. Again, that's pretty much it for today, guys. I think we covered everything, and we're exactly over an hour and a half. That's great. I wasn't expecting that. So, is there anything else you would like to say before we close this? Two people are writing something. That's good. There's a lot of questions. Thank you as well for being here, guys. My pleasure. But we'll get to more complex stuff like Vulkan and stuff like that slowly. We have to build up to it. You see, there's a lot of stuff a lot of ground to cover before that. Somebody else is writing something? UML from GitHub allows you to. That's pretty cool. Right. I see. It's good, guys. We can have some extra architectural documentation like that. That's good. I will keep it in mind. And with that, guys, I'll have to say good night to you all. Thank you very much for being here. And have a great weekend. And I'll see you soon.